we don't intend on boiling down your risk to one number. We don't believe that's possible either. What we want to do is add quantitative values to the uncertainty we have about potential future outcomes. We add some probabilities here. We say it can range from a highly likely event to a highly unlikely event, and the consequences can range from very low to very high. What is problematic about this is that we are adding in a new source of error to a risk assessment. And this is a source of error which is not inherent sort of to the expert input, but it is how they are asked to respond. So you can have an expert who have a good idea about where the impact might land, but the way we ask them the question actually produces worse answers than gut feeling would have done. And what you see is this term probable. Estimates range from something like 25% likely within the coming year to 90% likely within the coming year. You technically cannot be sure if this person has meant, well, it's something that happens once in every 4 years, or it might be something that we almost see every year. And to us, that's quite a big level of uncertainty, which is not expressed explicitly in this model. That, okay, we need to address this ambiguity. We can see this as a problem. Low, medium, high is not good enough for us. We need to add some numbers to this. So then you add numbers to each of the columns and each of the rows in order to sort of assist the respondent in how to answer. The issue is now we add values. We also assume that it's possible to do some kind of mathematics on this model here. So you have a green risk, which is 7 times more impactful on average than your yellow risk is. We take a very wide range of potential outcomes, and we try to plop them into a few boxes. And we make the assumption that our risk can only be placed in one box. And this is generally not true. Most of the risks we have looked at, they range much wider than just one box. So trying to place it into a box, again, goes back to the point where we add error unnecessarily to the interpretation of the expert judgment, for example. So another way to illustrate this challenge would be if you show it in a graph. Now, what you'll see is actually that the green risk can be as expensive, the number 3, as the risk scenario number 1, which is a red risk. So if I wanted to show you how these losses would look in a non-logarithmic model, this is what you get. And if you zoom in on the very leftmost millimeter of this graph, this is what you get. I hope this is a clear enough picture to you of once you start adding numbers to your risk matrix, you don't solve any issue. Rather, you just add another issue of challenging basic mathematics, which these matrices are not suited for. And you start adding error to a level where there have been studies showing examples of these matrices, the way they've been constructed, actually add more risk or more uncertainty, more error to your risk assessment than a pure gut feeling, write a sentence on what you expect this risk is.